Hello students. So in this particular video, we are going to discuss a particular question which involves integration as well as binomial theorem and limit. Okay, so the question here is limit n tends to infinity, sigma of k equals 0 to n nck by k raised to the power n k plus 3. Okay, so this is the question. We have to find the value of this question. Okay, so we'll see how beautifully we can actually solve this question. Okay, so let's see if I want to write this 1 upon k plus 3. Can we write this as limit n tends to infinity, sigma k equals 0 to n, nck by n raised to the power k, and can we write this as 0 to 1 x raised to the power k plus 2 dx. Now x raised to the power k plus 2 would become 1 upon k plus 3, right? So we can write this particular thing like this, right? Now, having written this, I can take this, I'm taking this x square. So I'm just changing the limits from here. So what I'm doing now is I'm writing this integration as limit n tends to infinity. Now here 0 to 1, I'm writing sigma of k equals 0 to n nck by n raised to the power k. Now this I'm writing as, here I'm writing as, wait, x raised to the power k. Okay. I'm writing this x square over here, dx. Okay, is this fine? Okay. So after this one, what I can do is, I can write here, now this becomes what? This becomes sigma k equals 0 to n nck x by n raised to the power k, right? Isn't this the binomial expression, right? You can write this as 0 to 1 x square, right? Dx limit n tends to infinity. Now this one, actually, this one I can write as limit n tends to infinity. What I can do is I can just put 0 to 1 x square here. I'm taking this one, I can write as 1 plus x by n raised to the power n, right? So I'm writing this as 1 plus x by n raised to the power n, right? X square is over here. I'm writing limit n tends to infinity over here, right? Now this thing becomes what? This is c. There's 1 plus t raised to the power t, where t tends to, here t tends to 0, because when n tends to infinity, x by n becomes 0, right? So this becomes 1 plus t raised to the power t. Now if I want to put this as t, I'll have to write n by x into x, right? Can I write this? Right? I can write this. Limit n tends to infinity, 1 plus x by n raised to the power n by x into x, right? Now what does this become? This is e, right? So this becomes e raised to the power x. This is e raised to the power x into x square, right? 0 to 1 dx. So what I'm doing is, after this, I'm writing the values over here. Okay. Let's say this value is 0 to 1. This is x square into e raised to the power x dx, right? I'm taking this as second function. This is first function, integration by parts, right? So first function into integration of second, right? Minus integral of derivative of first. First is 2x, right? Into integral of second, right? Dx from 0 to 1, right? So if I put 1, this becomes e. If I put 0, this becomes 0, right? Minus 2 times of. Now I have to again take this x is first function, this is second. So first function into integration of second. So x into e raised to the power x. The limits are 0 to 1 minus integral of derivative of first is 1, right? Integral of second is e raised to the power x from 0 to 1 dx, right? So how much has this become, right? So this is basically e minus twice of, if I put 1 over here, this becomes e, right? If I put 0, this becomes 0 minus. If I put, let's say the integral is e raised to the power x only. So if I write here x equals 1, it becomes e minus 1, right? So e minus 1 is 1 over here, right? So this becomes e minus 2, right? So the answer is e minus 2. So here we have used binomial over here. Then we have used limit over here. And we are obviously using integration over here, right? Okay, I hope this is clear to you. Okay, thanks a lot for watching this. Okay. Do like and subscribe the videos. Thank you. Thanks a lot.